Correlation coefficient grade 12 statistics. Okay, in this video we are going to learn how to interpret the correlation coefficient, but first let's start with an example. Okay, example. A group of students attended a course in statistics on Saturdays over a period of 10 months. The number of Saturdays on which a student was absent was recorded against the final mark the student obtained. The information is shown in the table below. Okay, this is the information. Now, you have 4 questions to answer. Okay, 1, 2, 3, 4. Okay, question 1, calculate the equation of the least squares regression line. Okay, 1, this is the equation that you need to calculate. You are going to find A and B. Okay, you are going to find A and B. So, you are going to use your calculator. Okay, I'm going to use my emulator. So, you are going to start with mode. Okay, this is mode. And then option 3 for stat. Okay, statistics. Option 3. After that, you have option 2 for A plus BX. Okay, A plus BX. Can you see A plus BX? Option 2. Now you can insert the information that you are given. Okay, this is your X and this is your Y. Okay, so your X, you have number of Saturdays absent, and Y, you have final mark. Okay, so you have 0. You press equal to insert it. After that, you have 1. Okay, you have 2 and 2 again. Carry on until 7. Okay, now we are going to insert Y. Okay, this is Y. You are going to shift to the right and then up. You make sure 0 goes together with 96. Okay, 96. You press equal to insert 96. And then after that, you have 91. Okay, 91. You press equal to insert 91. Okay, carry on until 56. Okay, so the information is in your calculator. Now you are going to press on or SC. Okay, on or SC. So you are going to press shift and then start. Can you see start above 1? So you are going to press 1. Okay, now you have this. You are going to press 5, option 5 for regression line. Okay, option 5 for regression. Okay, so 5. Now you have A and B and you also have R. Okay, we are going to find R in question 2. Okay, calculate the correlation coefficient. This is R. For now, we need A and B. So, to get A, you are going to press 1 and then equal. So, this is A. Okay, 91.27. 91.27. Now, to find B, you are going to press on or SC. Okay, on or SC. You are going to press shift again. You can see the information is still in the calculator. This is why you have start. So you are going to press shift and then start, which is above 1. So press 1. Option 5 for okay, regression. Now you need B, which is 2. You press equal. So B is equal to negative 4.91. Okay, negative 4.91. Negative 4.91. So we can close the calculator. Now you have A and B. So the equation is this. So this is the equation that you need to calculate. Now question 2. Calculate the correlation coefficient. you are going to use your calculator again. So the information is still in the calculator. Okay, you can see you have start, meaning the information is still in the calculator. So you are going to press shift and then start, which is above 1. Okay, you are going to press 1. You are going to press 5 for reg. Okay, regression 5. Now you need R, which is the correlation coefficient. Okay, R is the correlation coefficient. Okay, so you need 3. You are going to press 3 and then equal. This is negative 0.87. Okay, negative 0.87. So this is the correlation coefficient. Okay, now question 3. Comment on the strength of the correlation between the number of Saturdays absent and final mark. Okay, between the number of Saturdays absent and final mark. Comment on the strength of the correlation on this comment. So you can see this value is very close to -1. Okay, so this is strong because it is negative. You are going to say negative. So you are going to say there is a strong negative correlation between the number of Saturdays absent and final mark. Whenever you have the correlation coefficient negative, you have to know that the X values are increasing while the Y values are decreasing. Okay, whenever the correlation is negative. Okay, now question 4. Comment on the trend of the data. Okay, you can see from the data, the greater the number of Saturdays absent, okay, the greater the number of Saturdays absent, the lower the final mark. You can see that the lower the final mark. Okay, you can see there is an increase in the number of Saturdays absent. Okay, there is an increase. Okay, and there is a decrease in the final mark. You can see that there is a decrease. Okay, so the greater the number of Saturdays absent, the lower the final mark. Now, interpreting the correlation coefficient. Okay, correlation coefficient interpretation. The linear correlation coefficient R is a measure of the strength and direction of a relationship between two variables. So we call it linear because the relationship is measured using a straight line. So let's say you are given this scatter plot. How can you interpret the correlation coefficient? You are going to try to draw a straight line following this pattern. Okay, try to draw a straight line following this pattern, like this. Now, the closer this point tends to align on this line, the closer the value of R gets to 1. So this is approximately 0.9. This is going to be strong positive correlation. Let's say you are also given this scatter plot. To interpret the correlation coefficient, you are going to try to draw a line following this pattern. Okay, try to have the same number of points above the line and below the line. Okay, the same number of points above the line and below the line. Okay, so you are going to follow this pattern. So this is approximately negative 0.9. Okay, so this is strong negative correlation. So whenever the correlation coefficient is negative, you have to understand that the X values are increasing and the Y values are decreasing. Okay, increasing, decreasing. As you try to draw this line, you can see that. Okay, let's see other examples. Okay, you are given this scatter plot. Okay, to interpret the correlation coefficient. Okay, to interpret the value of the correlation coefficient, you are going to try to draw a straight line following this pattern. Okay, you can see how close this point they are trying to align on this line. Okay, how close these points are trying to align on this line. So this is approximately 0.7, less than 0.9, because the points are getting a bit far. So this value is going to be called moderately strong positive correlation or fairly strong positive correlation. Whenever you have the value of the correlation coefficient positive, you have to know that both x values and y values are increasing as you try to draw this straight line. You can see x is increasing and y is increasing as you try to draw this straight line. Okay, now let's say you are also given this scatter plot. Okay, when you try to draw a straight line following this pattern, you are going to see that it's decreasing. So this is approximately negative 0.7. Okay, and this is going to be called moderately or fairly strong negative correlation. Okay, negative, because this is negative. Let's see another example. You are given this scatter plot. You try to draw a straight line following this pattern. You are going to have this. So this is approximately 0.4. So this is going to be called weak positive correlation. Let's say you are also given this scatter plot. When you try to draw a straight line following this pattern, you are going to have this. Now you have R approximately negative 0.4. So you are going to call this weak negative correlation. Let's say you are also given this scatter plot. In this situation, there is no pattern to follow. You don't have a pattern that you can follow to draw a straight line. So the points do not tend to form a straight line. So R is equal to 0. No correlation. R is equal to 0. No correlation between X and Y. Okay? Let's say you are given this scatter plot. Now, if you try to draw a straight line following this pattern, you are going to see that the points lie exactly on top of this line. So R is equal to 1. This is a perfect correlation, perfect positive correlation. Whenever you have this situation, all the points, they are exactly on top of this line. Okay? And let's say you are also given this scatter plot. When you try to draw a straight line, you can see the points lie exactly on top of this line. R is equal to negative 1. So this is perfect negative correlation. Negative because this is negative. Negative, decreasing. Okay, you have to know that X values are increasing and Y values are also increasing. But whenever you have a negative value increase in the X values and Y decreasing, okay, decrease in the Y values, you can see that as you try to draw this line, the X values are increasing and the Y values are decreasing as you try to draw this line. But here you have X increasing, Y increasing as you try to draw this line. Now the correlation coefficient range interpretation. Okay, the correlation coefficient range interpretation. This is the range. Okay, from negative 1 to 1. When it is negative 1, perfect negative correlation. Okay, perfect negative correlation. When it is positive, perfect positive correlation. Okay, perfect positive correlation. Whenever you have a positive 1, okay, whenever you have a negative 1, okay, now the values, how can you interpret in between? So you need this. Okay, you need this. You are going to use this to interpret. Whenever R is equal to negative 1, perfect negative correlation. Whenever R is equal to a positive one, perfect positive correlation. Whenever R is equal to 0, no correlation. Okay, whenever R is in between negative 1 and negative 0.8, equal to negative 0.8. Okay, equal to negative 0.8, strong negative correlation. Okay, you can see that